Hello, Year 9. So today we're looking at 0 and negative indices. So 0 or some negative values for the index number. Looking at our starter now. It's on surds. It's a little bit of a tricky one, but think about simplifying the surds first before adding or subtracting. So pause while you're working on those. Welcome back. So let's have a look at the answers. So the first one, that root 50, simplify that to 5 root 2 by recognizing that biggest square number that is a factor of 50 is 25. Same with the 32. Should have seen that 16 is a factor of 32, so you end up with 4 root 2. A little bit of a more difficult one, I thought. This one, where we've got 7 minus 2 root 21, so you end up with 5 root 21. And there we go, that's our last one. Okay, so we're looking at some negative and 0 values for our index number. So we look here, I've already started the table. We've got 2 to the power 4, so that's 2 times 2 times 2 times 2, which is 16. 2 to the power 3, which would be 8. Then we've got 2 to the power 2, which is 2 squared. We should know that is 4. And then if we look at 2 to the power 1, so it's just 2. Let's look at what's happening as we go down this table. What's happening to these numbers? We've got 16, 8, 4, and 2. So you should have spotted we're halving them, or divided by 2. So 2 to the power 0 must be 2 divided by 2, which is 1. And anything to the power 0 is 1. So then we're going to do our next one. What would be half of 1? It would be 1/2, or 1 over 2. Half of a half is 1 over 4. So we'll have a look at why that is a little bit more clearly in a little bit. The same thing we could see happening here. So we'd end up with 3 squared, 3 times 3, well that's just 9. Then 3 would be 3, and we've already said that anything to the power 0 is 1. So what's happening here? We're dividing by 3 as we go down the column. So we should have a third here, then a third divided by 3, which would be 1/9. So let's have a look at a couple of examples. So our first, side heading examples, examples 1, right? So let's look at 5 to the power minus 2. That'd be exactly the same as saying 1 over 5 to the power of positive 2. So all we've done is say we've got 1 over 5 squared. So we should know what 5 squared is. It's 25. So let's look at example B now. All we've got is 1 over 2 to the power 3. 2 to the power 3 is obviously 8. So we've got 1 over 8. So in the task you're going to do next, what we're looking for, or what I'm looking for, is to have it in your answer in this form and in this form. Okay, so side heading main task. Right, so this should only take about 5 minutes. So pause it while you're working on them. Welcome back, Year 9. So let's have a look at the answers. So we should have in the form of 1 over something to the power of something, and as 1 over just a number. So again, obviously marking your own. If you've made any mistakes, have a look back and see if you can work out where you've gone wrong. Oops. So let's look at now, we've got side heading examples 2. Okay, so our first one, I'm going to move over the board a little bit just to make myself some more room. Right, so 1/2 to the power minus 2, that would equal 2 over 1 to the power 1. So all that means is we're going to say 2 to the power 1 over 1 to the power 1. So anything to the power 1 is just itself. So we've got 2 divided by 1, which is obviously simply 2. So we look at our second example now. So we've got 1/3 to the power minus 2. So we invert that, we'd have 3 over 1 to the power 2, positive 2, which would be 3 squared over 1 squared, which is obviously only 1. 3 squared is obviously 9. 9 divided by 1 is 1. So far so simple. The last one is slightly more difficult, but as long as we follow the same steps, we should be fine. So we're going to end up with, so we've got 2/3 to the power minus 3. So if we invert the fraction to make it 3 over 2, 3 over 2, my goodness, 3 over 2 to the power 3. Right, and we're going to end up with 3 to the power 3 over 2 to the power 3. So 3 to the power 3 is 3 times 3 times 3. So 3 squared is 9 times 3 again, 27. 2 squared is 4 times 2 again is 8. So you could change that to a mixed number, 3 3/8, but it's usually best to leave it as an improper fraction. So side headed main task 2. So we've got 10-15 minutes this should take. There is a challenge question, but we'll have a look at that question if you want to have a go at it after we've looked at these. So while you're working on it, pause. So welcome back. Let's have a look at the answers. Again, marking your own. Anything you've got wrong, have a look through and see if you can work out where you've gone wrong. Okay, so here's our challenge question. Our challenge questions, sorry. Quite tricky, I think. So if you choose to have a go at the challenge questions, pause while you're doing them. So welcome back. Let's have a look at the answers to the challenge questions. There we go. Right, so our checking questions now. Checking questions. All right, so our first one, should have seen that is, we'll do my answers up here. We got 1 over 4 squared plus 2 to the power 4 over 1. It's 4 squared even. Okay, so we should have ended up with 1/16 plus 16 over 1. So you could see already that that would be 16 and 1/16, right? But we might want that as an improper fraction. So if we think about how we've added fractions in the past, we've got to make the denominators the same. So I've multiplied this 16 over 1. I've multiplied the denominator by 16. I've got to do the same to the numerator. So 16 times 16 would be 256. Then obviously we've just got 1 plus 256 would be 257 over 16. Right, let's have a look at B now. Hope I'm going to have enough room. So we have got, we're going to end up with we've got root 5. Oh my goodness, this isn't very good. I don't know how to see if I could erase this. There we got rid of everything. Okay, so we'll start this one again up by here. So we should have ended up, so first thing we're going to invert that fraction. So we've got root 5 over 3 squared, plus we're going to invert this one as well. So we've got 4 over 6 squared. So if we look at just taking those brackets away, we'd be looking at root 5 squared, which is obviously 5, over 3 squared, which is 9. Then we're looking at the second part, we're looking at 4 squared, which is 16, over 6 squared, which is 36. So again, we know we need a common denominator. So 36 is a multiple of 9. So we can keep 36 as it is. Obviously, it is 4 times 9. So we're multiplying the 9 here by 4 to get, to get 36. And we've got to do the same thing to the top. So 4 times 5 is 20. So 20 plus 16 is 36 over 36, which is 1. So thank you very much, Year 9. I will see you again.